Hello. All right. I'm just gonna get into it. Welcome to the weekly update. I do this every week to talk about Sausage Sports Club and how I did, like what I did this week and how the game's going. I like to do this for 3 reasons. One, I think it's useful for students or new developers to see like how things work and get to see like the whole process of making a game. It's also important to like show the new stuff in the game for marketing, so more people will learn about the game and hopefully buy it once the game comes out. And then also as a way to kind of record my progress as a designer and developer, so in 5 years or 10 years or whatever I can look back and see, oh, this was when I learned this thing, this is when I learned that thing, oh, I used to be good at doing this but now I'm not as good, so maybe I could learn from watching myself in the past. Or, you know, if somebody asks me like, how'd you do this thing, I can just point them to the update video and they can see it that way. So that's what I'm doing. Let's talk about what I did this week. Most of it was this new map, Tiny Tokyo. It's pretty close to being done now. I still have to do a little bit of, let me pause my music. I still have to do a little bit of setup for paint mode. There's like a pretty specific workflow just for that mode where I have to set up special materials and make sure all the materials react properly when you're painting, and they have to, different parts of the map have to be the right scale on the light map and everything, so it's a little bit involved. It's not done yet. Let me pop in here. Let's just do mode select, do some bots, just so you can like see the context of what I'm talking about. I spent most of the week like making this map from scratch, and then I spent about a day. Let's move the audio. Did I break it? What's going on? Mode select Tokyo Scout. What's the deal? There we go. Remove the audio. Yes, this is the map. It's, as you can see, it's kind of like a version of Tokyo where your characters are the size of kaiju relative to the buildings, and a bunch of the buildings are destructible. And there's like the Tiny Tokyo landmark. And there's like a train kind of going around the city, or I guess two trains, but there's a train track. Oh, and I still need to set up the collision as well, so the players can't just like walk out of the map. Let's jump on this train. There's also little vehicles that drive around. Those are pretty silly. Oops. Okay. So that's the gist that I wanted to give you. Let's just jump right into this stuff. So there's a bunch of like interesting little bits and pieces that like make up this map. I'll leave that there. Okay, so I'm just gonna like hop through these like kind of quick. I don't want to get like too wrapped up in the technical side of it. But start with the trees. I posted a bunch on Twitter about these trees. You might be able to tell if you're looking closely at them that instead of being a 3D model, each of these trees is just a sprite that billboards and like faces the camera. If I pick one and get really close to it, you should be able to tell. Yeah, see how it's just like a card facing the camera. If I go to wireframe mode, you can see that it's, you know, it's just a couple of verts. And this was originally like how I was going to optimize so that I could have as many trees as I wanted. I think there's like 700, maybe 800. And when I had models and they weren't instanced, they were just static, it was taking a super long time to bake those, bake the light maps for those, and I just didn't really want to wait that long. It didn't feel necessary. to, you know, to have that many polygons on screen. I think I was getting up to over 1 million polygons from that, whereas once everything's batched, I think it's under, maybe it's like 250,000 or something. I can just hit play again to see. So I came up with this idea of, I'll just take, you know, I'll take a picture of each of my trees, and then I'll put that on a card, and I'll, in the shader, I'll like tell the verts of that card, you know, of that quad, just to like aim at the camera, and that worked pretty good. Yeah, so we're like under 300,000 triangles. Which is pretty good. If all of those trees were meshes, that would be like 500,000, and that's not really the bottleneck of Switch, but there is a number of verts that becomes too many, and I'd rather not get close to that. The other cool thing about these trees is that they're instanced, so instead of each tree being its own, you know, sending each tree separately to the graphics card, they're all being, there's only one being, or because there's 4 variations of trees, each one of those variations is sent once, and then we also say, also draw this mesh with this material at all of these positions, rotation, scales, whatever. They all have the same rotation and scale, I believe, but that's the idea of instancing. And that makes it so it's only, I think it's only 4 draw calls. Or no, it's a little bit more than that, because there's like the depth. They have to be rendered for depth as well, so I think it's 8 draw calls, but that's fine. It's just a big optimization. Let's go to the next thing. The train track. Okay, so this is interesting, and I'll come back to this. Do I'm gonna do it later. Modeling with splines. Yeah, I'll come back to that a little bit later, but there's this train track, and this train is, you know, it's a dynamic thing that moves along the train track, and this is done using a spline. Whoop. It's a little hard to see because of these box sliders, but here we go. I've got this, it's kind of a wire. If you're not familiar with splines, it's kind of a wire, continuous line that's like bendy, and you control it with these control points. And so I have, you know, I have a series of control points, and those all together are fed into a math function, and that defines like what the shape of this line is. And from code, I can get, if I say I want some percent along the line, 5, 10, 15%, whatever, I can get the position at that point along the line, or I can get the direction that the line is heading. And I didn't need to do this for the train, but I can also store arbitrary data at each one of these control points, and then given the percent along the spline, I can interpolate between those arbitrary data at the control points and get like, let's say I have like, a good example of this is the crabs in the game. They use a spline to like crawl out of the water and then crawl onto land, and I do that by defining at the bottom of the spline. I say like, here's the direction I want the crabs up to face, and then once they get on the ground, or at the end of the control point of the spline, there's only 2. I define another direction that's the way I want the crabs up to face, and so by doing that, I can have the crab like crawl up with its head pointing like straight out from the wall, and then once it gets to the top, then its head's pointing straight up off the ground. And you could, you could like extrapolate that from the splines data of saying like, if I have like 5% along the spline, let's say that's like where my mouse is, and then I look at 5.1%, then I can use that direction, or sorry, I can get the direction and then use like the cross product to get the up at that point. But if I want to like define it specifically to be something weird, like not like the crab's up direction, then you might want to put some like weird data in there Maybe you're like having your character spiral around the spline or whatever. That would be a good way to do it. Yeah, so the train like travels along the spline. It was easy to define the spline to like kind of match up to the train track I modeled. I didn't do any weird code to like make it line up exactly. I just like hand placed it. And then you can see there's like all these colliders along the spline. Those were placed programmatically. There's this component over here on the thing where I can say like place these colliders, and I'm gonna have a number of boxes I want, and then it just goes, it divides the spline into whatever number is here, and then places a box along each section that matches these size coordinates. So that was an interesting kind of, I knew I wanted a train that could carry the player around, and it was an interesting design problem of like, okay, how am I gonna make this track? How am I gonna make the train move along the track? How am I gonna place? Once I had it, I was like, oh, this is kind of like a weird, crazy mesh. It's like long and bendy, and if I put a mesh collider on it, then it's gonna like, unless I split it into several meshes, then it's gonna like not be able to spatially partition the players to be obviously away from the track, because the track is a big circle and it surrounds all the players, so it would always be trying to like intersect. But the box sliders are a good solution for that. So some fun problem solving. So that's the track. Buildings are interesting. I don't remember if I talked about this last week. And if I did, feel free to interrupt me and say you already talked about this. I think I maybe did a little bit, but I'll briefly go over it. So, like I mentioned, all the buildings in Tokyo are destructible, or a bunch of them are, not all of them. And I tried. Initially, I thought about using like an automated, an automatic mesh kind of cut up either thing in Unity, where it like real time splits it into bits and then explodes, and that wasn't going to be performer on Switch, so I didn't do that. And then I thought, oh, maybe I can use Maya's tools to like shatter a mesh, and maybe that will work. And I tried that, and Maya spit out a bunch of like high poly stuff that would have required a ton of cleanup. So in the end, I ended up just like manually going over. I would finish the building, clean that up as much as I wanted it to be, and then I'd manually like be like, oh, this would be an interesting shape, I'll just cut a line, and then I'd clean that up. That ended up being faster than if I were to use Maya's tools, or it computationally is like okay to do on Switch because it's just a few more pieces. And then in the game, I have this prefab that I set up, which contains the shatter pieces and also the full version of the building. When the match starts, I hide all of the shatter pieces and show only the solid piece. And then I detect collisions against the like box colliders of this main piece. Sure, this guy's just one, but some of them have a few because there's a regular shape. Anyway, I detect collision, and once players have hit, or balls have hit, or the player has stomped on this building enough times, which for most of them is just one time. Only for the like tallest tower, this one, is it 2 times, just because it's more fun to like immediately break a thing than to have to hit it a few times. Then I turn off the main single building, and I turn on all the little pieces, and I make them, non-kinematic, and then they can get all over the place. And then the more interesting thing is I want these buildings to. It's really fun to break buildings, so I want them to come back, and you could be able to do it again. So once the buildings either fall into the water and like fall off screen enough that they're basically gone, or if their rigid body goes to sleep, which means they stop moving long enough for the physics engine to like stop calculating stuff for them until they're hit again, If either of those happen, then I say, okay, time to reset this building. If the pieces are on the ground, they sink into the ground and disappear, or if they're off screen, they just disappear. And then we turn back on our single building, turn off our our shattered pieces, and then we kind of like wiggle the building up through the ground. I can show you that too. And that makes it not only is it like you get to keep destroying buildings and that's fun, but it's also like not even that noticeable if you're not looking. So you and your friends might be like playing soccer and you run over to the side and then you come back around and you still have more stuff to destroy, but you didn't even realize it was gone. Yeah, so you could see it there. Fly over to it. Whoop. There we go. It's gonna happen right here. Yeah, there you go. And then the flamingo knocks it down again. So that's that. Bending trees. This will be a quick one. I knew from the start of making this map, and I had thought about this map for a while. I knew I'd wanted to make it for like 2 or 3 months. But I knew something I wanted to do is to have a park in the city, and if you walk in the trees in the park, the trees would react to the players, and so they do that. And this is just a simple in the vertex shader of these trees, they just simply move away from the player based on how close the player is to that where the vertex originally was. If they're super close, then they get offset a lot, and if they're farther away, they don't get offset at all. So that's all that is. And maybe I haven't really talked about this on the stream, but thanks, Becca. I haven't talked about this on stream, but I made a tool that combines a bunch of meshes into a single mesh, which is kind of like the instancing thing I mentioned before, but I'm doing it manually, and that's useful for a couple reasons. Like, it's easier to turn this on or off. It's easier to just bake lights of one thing than to bake 50 different objects or whatever. And it's cheaper to draw. It's cheaper to draw something as one material. If you don't have to statically batch it, then you get it for free basically. There's nothing that interesting there. Here's my notepad. Okay, modeling with splines. This one will be interesting. Kill that. I'll just show you an example of this. Maya has these really cool tools of making curves, and so like the Bezier, like the spline I showed you before, where you can like define these control points and like bend them around. Maya has those as well. Cool. So we got this curve, and then the other really cool thing that Maya has is, and let's do this with a tunnel. I'll make a tunnel just as an example. First let me split it a bunch of times. Whoop. So that one's big. It's a big tunnel. Make it thin. Okay, so this is kind of an unusual problem. Like, generally you like don't have to do this, or maybe this isn't the way that you think about it. It wasn't the way I thought about it. But if I wanna, I didn't change the thickness. Let's make it like 1.2. Okay, so there's our tunnel. Usually I feel like this would have a programmatic solution where like in the game engine you like make the tunnel for like a procedural game or something, but if I want to make like a winding tunnel in a game, it's kind of, you don't want to like model that by hand. I got a puppy under my desk right now. But one way you can do that is to use these curve tools. Rigging. Where's constraints? Constraint. Okay, cool. So I can tell this mesh like I want you to be attached to the path, and it'll do that. It looks kind of silly because it's a motion path. The assumed use, which I never use it for, is to, you know, move along the whole path. So it, for whatever reason, it like automatically keyframes like the position to match up the spline curve or whatever. But if you go into constraints again, do motion paths again, but change it to flow path object, then you get a more interesting thing. You get this weird shape, and there's like, you can kind of see there's this lattice, this like box with like this cut out box along it. If you tweak these settings, you can suddenly do like this really weird. The more times you oh man, I crashed. That's okay. We'll just open Maya again. Yeah, so then if you add a bunch of subdivisions, you can have the entire tunnel kind of like mapped to the curve. Bezier. Okay, let's do like a spiral curve, and then we'll like jump it over. Whoops. Control vertex. So we've got a cool tunnel now. Pop this one up a little bit. Okay. Hopefully I don't crash again. Alright, let's map it to the curve. Rigging, constrain. And the reason I'm mentioning this is because I used it for the train track. You can, there you go. Looks like our tunnel is too thick, but don't worry, we can tweak the spline. Oop. You can do it despite having already like, you know, mapped this thing to it. That's a cool thing about Maya. There we go. And there's probably a better way to like save this out, but what I've done is I usually just duplicate the existing mesh and then delete the original one, and that like leaves me with the end version. So now I've got this cool tunnel. It only took, not counting the crash, it only took like 2 minutes. Then let's go back to Unity. That's how I made the track. Worked out pretty good. Oh, and it's also how I made these power lines. It's much easier than like modeling them out by hand. Okay. I think trees, I showed that. Tiny vehicles. Okay, that one's interesting. So the thing about a city, one of the defining things that makes a city look like a city is that it's kind of bustling, like it's alive, there's people moving, there's stuff going on. And this, until I added these cars and ambulances and vans and everything, the city looked super boring and like nothing was happening. But now, you know, besides the kaiju animals like jumping around and playing games, but now with these vehicles, it kind of has a sense of like life on its own, besides what what we're doing here that makes it feel alive. And you can also, of course, like knock stuff around, and the cars will blow up, and new cars will spawn and stuff. Boom. You can hit stuff into the water, yeah. So I think the interesting thing about these is that they're kind of all managed from one system. Like one component manages all these vehicles, like moves them all around and determines when they're dead and stuff. It also determines like which ones should spawn and how often and how fast each of the vehicles move. And I did that because I knew I wanted to have an arbitrary number of them, and for every component that's running an update loop or a fixed update loop, which is what my vehicles need, it's just like more weight. It's like more computing power. Like every frame, there's like a number of fixed updates. I think it's four or six per frame. If I have, let's say I have 18 vehicles, that's how many I have at max. If I have 18 vehicles and each is running 4 per frame, that's 72 fixed update ticks per frame. And like just the fact that they're ticking like costs something, and just the fact that the components exist costs something. And so to avoid that, I put everything on this one component. Let's go in here. I'm not going to get too deep into the code because I know it's not like super interesting to, unless you're a programmer, it's not super interesting to talk about. But to keep it simple, I run through all of the vehicles every fixed update, and they all have a path that they're moving along. They have an endpoint that they're trying to get to, and they follow a path that has been created for them. And this purple kind of area of the nav mesh is like what they're allowed to travel along. So they have to find a point on this purple section, and then they say, I'm going to make a path to that point, but I have to travel along the purple part. And then every frame we look at the path that's defined and say like, okay, I move this past per frame, so if I move as fast as I can, here's the point I'll end up at. If I like, I don't want to get into the like path navigation logic, but so each car moves along its path, and then their positions all get updated, and it's well optimized, suffice it to say. And then they also do the same thing I mentioned before with the buildings, where if their rigid body is falling asleep because they haven't moved for too long, or if they're very far off screen, then we just like tell them to explode and we spawn a new vehicle basically. Oh, and when they get hit, when a vehicle gets hit, either from somebody doing a stomp near them, or from what's the other thing? Or from literally physically getting hit by a dynamic object moving above a certain speed, then we like tell them, okay, you aren't controlled by us anymore. You're kind of like free flow. It's one system right. Didn't take very long, which is what you want. Okay, so that's all the like little interesting tidbits of Tiny Tokyo. Some kind of like higher level ideas I wanted to talk about that kind of came up with Tiny Tokyo. And one of them I've talked about before, which is like optimizing your workflow to like keep yourself happy and like make the thing you're doing fun to do is really important. And these kind of relate to that. And this kind of came up again as I was working on this, because I wasn't really thinking about my process, and I just kind of was like, okay, I'm gonna just keep working on stuff, I'm gonna keep making stuff, but I wasn't thinking about like how to organize my files and how to make sure that I wasn't going to break things as I was working. So if you've worked on a game, this will probably be a familiar idea to you. Okay, so I have this layout. I started with this layout of Tiny Tokyo, and if I select it, and you can see, and I move it, you can see that's like most of the city kind of stuff. But that's kind of misleading because the actual asset, the actual like mesh of it, is just that much stuff. Or no, let's go deeper. I guess it is that much stuff. So we're missing a bunch of stuff here. We're missing the train, we're missing the supports, we're missing the kind of wire and buildings in the background, we're missing this dam, or sorry, this tunnel out of the city. And we're missing the trees, but that's fine. And the problem with this is when editing any of these things separately, when editing this piece separately, or when editing this piece separately, or when editing the train track separately, and that one was the biggest issue. If I accidentally moved any of these things a little bit, it kind of like screwed up the entire map, and I had to figure out, oh, what's wrong here? Like, do I need to... Is the mesh correct now? Was it wrong before, and now that it's updated, I need to fix it in the scene, or should I go back to the way it was before in the mesh? Do I still have the history on the object in Maya so that I can go back, or is it gone? Because I've like edited a bunch now. And then all these little questions and like problems you're trying to solve at that point are like things you don't want to have to deal with, and don't have to deal with if you like are considerate about your workflow and like make things easy for yourself in the future. So what I should have done instead of that is I should have kept the train track and the tunnel here and this background stuff all in the same Maya scene, and either exported them all as the same object, or if I kept them in the same scene, then I know like at least all of the stuff is relative to each other. But instead, I like, when I first made the train track, I made it on top of the, on top of my layout in Maya, but then I exported it separately, and so then they became separate, and then later I was editing the train track, and I made a little change, and then I exported it back, and it suddenly was like in a very different position. And later on in making the map, I decided, oh, this is way too big, I need to scale down the whole map, and I did that in... I believe I did that in Maya. I forget. Layout. Yeah, I must have done that in Maya. And then once I did that, then the train track wasn't in that same file at the time, so then it wasn't scaled properly, so then I had to manually open the train track and then like scale that to match instead of having them both in the same file and doing that all at once. And all of these little like, oh no, I broke it, I need to fix it, I need to go do this thing, I need to think about how to like resolve these issues that I shouldn't have in the first place. All of these things compounded to make me not want to make more edits. All these things compounded to, if I like am reviewing the map and I'm like, oh, I don't like this, I don't like that, then I'm kind of like, oh man, but if I mess with that, it's gonna make me have to redo that part of the train, and the train, I'm gonna have to adjust the train track so that it matches, and I'm gonna have to adjust the trees again and all this stuff. So the idea that I'm getting at is my workflow was bad and wasn't well thought out, and so as a result now I'm like kind of censoring myself to save myself from having to do a bunch of extra work as a result of these interesting changes I want to explore. And that's really dangerous in doing creative work. If you're making it really hard for you to edit your work or to improve your work, then you're down the line, let's say, then you're really kind of doing yourself a disservice and doing the project a disservice. And I think I've gotten pretty good at like thinking about my workflow. This was just kind of like a small misstep that made me think about this again. The overworld, for example, I've been really good about keeping most things in one file so it's easy to edit until as late as possible in the process with an area. And it's taking a long time to load the overworld. Okay, cool. Oh, we're still loading. There we go. Whew. There we go. I recently upped the size of my light map atlas in the overworld to very big, and that allowed certain parts of the overworld to kind of have a better light map, if that makes sense. Like this piece specifically is wider than half of the 4096, which means it couldn't have fit in the 2048, which is my previous size. And so that maybe this one too. It's hard to tell. Anyway, I baked it again. I'm getting better results now, I think. This thing looks kind of weird. So like weirdly shiny. Look at my cube map's not big. I don't want to get too much into this. Oh no, it's a reflection code. Okay, that's fixing it. I just bake, yeah, bake all of them. When I finished this doing the light bake again of the overworld, everything kind of looked a little bit weird, and that was why. Because for some reason the reflection probes didn't all get baked. Okay, everything looks good again. Let's move on to the next thing on the list. Why did I come? Oh yeah, the overworld is like mostly in one file. Hub layout. So I plop this over. So you can see there's just like a lot of stuff in this scene, and a lot of it I replaced. Like you can see these rocks are like pretty low poly. They're not really like good looking rocks. And eventually I replaced those, or like this dock is like obviously a placeholder. Or these like tree trunks are placeholder. And I might replace those in the scene rather than in this file, so that for various reasons, but mostly because once it's final, I know I'm not going to change it, and rather than have like rather than have that file be a super high poly, I can just like if I make it a separate asset and then just place it in that same position and disable the old version, then it's just like a better. Then every time I import the hub layout or the overworld layout, doesn't take as long, and it's easier to like go back and forth between Maya. Can't see my hands. And quickly I will show you what that scene looks like in Maya, just so you can see like why it's easier for me to work on it. Yeah, so if I can see everything at once rather than seeing like, if I was just seeing this landmass, I can see its size relative to other stuff, and I can see its positioning relative to other stuff, and it's just like, it makes more sense to do it that way. And it's worth noting that it's not all one mesh, it's just all in one scene, so there's like, and this kind of hierarchy of objects exports to Unity in the same way. So that they will all be separate game objects, and if I parent something to something else, then that will carry over like like this thing is like the hub, and these buildings are all parented to this object, and so that like that hierarchy gets exported into Unity. And it's just kind of the workflow that I like. It might not be for everybody, but Sportsville. Oh, the other thing worth mentioning is because of the type of game this is, where it's kind of a platformer and you kind of want to jump on everything, and people are going to do that. It's really, it makes my life a lot easier if I don't have to manually go onto every new model that I make and say like, I want collision to happen here, I want collision to happen here. And so to that end, I have this component called auto collision setup on the top of my layout. That's on the, you know, on the top of this hierarchy of this entire scene, or on the top of this hierarchy of objects. Scene has another meaning, so I don't want to use that word. But this object, every time the scene gets loaded, it runs over every child component and adds a mesh collider component to anything. And sometimes it's like an empty game object, and it goes over every, I love the train pads. It goes over every object with a mesh renderer and adds a mesh collider. And that's like not always what you want, but it's mostly what you want. An example of when you might not want that is for these trees. Like, I don't want this tree to have a mesh collider on it, because that would be like a crazy mesh, and a capsule totally suffices, or you know, a simplified mesh is what you really want. But when I first throw stuff in and I'm first, you know, blocking out a space, I just want to be able to jump on stuff and see how it feels to navigate. And if I have to add them, you know, if I have to drop a mesh collider or like set up boxes and everything, it's not, that workflow is going to be crazy slow. This water looks weird. It's like not blue enough. I want to change this grass color. I'll come back to it. It doesn't matter right now. So that's the other thing of improving your workflow. Those are two ways I do it. But you know, your workflow is going to be different. Your game's different. Okay, let's talk about switch optimization stuff a little bit. And this is going to be, some of this is going to be Unity specific, some of it's not. Basically, the impetus for I spent a day a whole day this week just working on switch optimization, thinking hard about like what can I do to improve the game, like trying a bunch of stuff, doing a lot of profiling, making a lot of builds, and just like seeing what worked and what didn't work. And I have some notes from it, basically. The biggest one, and the thing that was the impetus for me to spend, you know, like the day or whatever on the Switch build, is that my builds were taking, the game was taking a long time to open, like to boot when you first open it on Switch. It was taking about 30 seconds, and that's like really crazy, especially for the size and type of game that it is. It's just like not what people would expect when they open it. And I looked at other, you know, I looked at my friends' games who are also making games in Unity, and you know, I tried opening their games and seeing how long it took, and that was like at least twice as long as it should take. So I knew I needed to improve that, and so I started trying a bunch of stuff, and looking at my, I'll kind of walk through my logic a little bit. Go to my manager scene. Plugins, so scenes, managers. Okay. So I knew when the game opens, I load to the manager scene, which is where all my like setup stuff is and where all the kind of like systems management objects are, I would say. I don't need to talk about each of these, but the type of things in here are the camera and all the settings and setup that has, the sound system and all the we use Fabric, which I wouldn't use again, but it's been okay. This is where Tom and Marty come in to like set up all the sound effects and tweak all the settings and stuff. There's also the game manager, which is like kind of where the game object lives, or the game logic lives, and where when I say I want to play soccer on this map, this is the thing where we like say, okay, we're gonna load, like we go through the logic of like, okay, here's what we need to load, here's how we're gonna set up the players, here's the stuff we need to spawn. All of that is kind of like driven through the game manager. And there's I could talk a lot about how that works, but I'm not gonna get into it. The idea is this scene is where all of these kind of like far-reaching systems live. And when the game starts up, we need to get all, we need to load all that stuff and get all that stuff ready so that the rest of the game can work. A big part of that is UI. All the UI hierarchies, like all the menus and all the character select and all this stuff. And when I was thinking about like booting up and why is this taking so long, I knew something was up in this scene. I knew something was going on in the manager scene that was making this take a really long time. So I came here, started looking around, looked at my UI, thought, well, there's kind of a lot of game objects. Child count. If I print that, there's 357 game objects. They all, within my entire all of my UI, there's that many game objects. A lot of those, I would say, maybe most of them even have like one or more components on them, and then each component has its own kind of startup logic and logic that's more expensive than just like empty game objects or something, or like a mesh. So I thought maybe that's a source of complexity. I tried just disabling all of the UI and then making a build and loading up. Same. Maybe I got like a quarter of a second back, so it's basically nothing. And I believe that's because all of these game objects are disabled until they're used, and that's when they're turned on is when all of the like setup logic happens. The only cost that's incurred from just having a lot of game objects is unload. The engine, like Unity's system, has to like parse the scene file and then like set up this hierarchy of stuff and say like spawn this component, that component, like set up all the data and stuff, but it doesn't run any logic until the game object is like awake or enabled or whatever. So that wasn't the issue. So UI is out, that's fine. Object pool is another obvious one. In a game like Sausage Sports Club, there's a lot of things that get spawned at arbitrary times in the game, like particle effects, sound effects, players, physics objects, soccer balls, paintballs, fireworks, all this stuff, just like a bunch of stuff. And these all get spawned at arbitrary times, and if you make games, you might already know that spawning a new thing from scratch is a lot more expensive than taking an existing game object and putting it at a position and turning it on and playing whatever particle system. So I use this system of object pooling to reuse objects that I've already spawned, and the way the object pool works here is at the start of the game it spawns just a pile of deactivated stuffs, like does the expensive part up front during a loading screen or whatever. So during the game there's not like hitches, and it's not slowing down the game or like taking up more memory in the middle of the game. It's just using existing stuff, and that's totally a common technique. And I thought, maybe spawning, and let's print what it is now. So there's this like pool at startup spawns like 300 objects. When I started, it was about 1,000, and that's, I thought, oh, spawning 1,000 game objects, that's terrible. There's no reason to do that. And that was true, and it got me back a little bit. I think it got me back like a second or 2 seconds or something of time at start. And my solution to that was to there are 2 things. One is, instead of spawning all 1,000 objects on one frame, I spawn here I can see I chose to do, I can move it over. Well, it doesn't really matter. I choose to spawn 50 of these objects per frame until they're done. So with my, with my 300 objects, that's 6 frames. That's 1/10 of a second, no big deal. With 1,000, it's a lot more. It's 200 frames, which is like 4 seconds. And that's, it's a little bit more, but still no big deal. And that didn't really speed up the start of the game. Yeah, it didn't speed up the start of the game. It just like kept chug happening over a few frames instead of just being 1 frame. The other thing I did, which helped a little bit more, is instead of spawning all of the stuff, or instead of setting up all of the objects that the pool would usually need on frame 1, which is 1,000 objects, I split those up into various scenes and into scene-specific pools. So when you load Tiny Tokyo, you need all these cars, you need building destruction, VFX, stuff like that. And instead of spawning those at the start of the game before you need them, just spawn them the first time you load Tiny Tokyo. So that, that offloads some 200 game objects to various places in the scene. So now, instead of the front of the game when you're trying to get started taking 4 or 5 seconds longer, displace that to Tiny Tokyo's. So when you load Tiny Tokyo, it takes 1 second longer, and the aquarium takes 1 second longer, and whatever else takes 1 second longer the first time you load it, and then it's faster every time after that. So that was like a nice little time back. So what ended up being the biggest thing to win like time to bring our time down of like startup is switching from using resources.load, which is a Unity API call that lets you do a really simple call. I don't have any examples of it in code, but it's just like resources.load. You can do load all of some type. So maybe it's like prefab, so I do game object, and then I can say in, it assumes resources, and then maybe we say like characters, and then like hats. Let's say we load all the hats. So I do this call, and this call alone was like, I forget how long, but once I was doing this call at the start of the game, like I think I was doing it 20 times or 15 times or something like that. Let me actually go look. I don't want bullshit numbers if I can help it. Yeah, let's see. Resources.load. Okay, here. So for each game type, and then for each scene, we use resources load. So we do it 20 times just for like the game mode or the game state payloads or whatever. Or really it's 25 times including mode select. So it's 25 times. Then we do another 5 times. Is that right? Game scenes. We do so we do it 20 times for that, or 25 times for loading the mode payloads. Then we do another maybe 8 times to get all the spawn payloads. Then we do player where I think it was probably upwards of 50 times. That's probably what it was. Like somewhere in that number range. I think I had. Let's see. I can probably remember. I know I got back about 5 seconds from switching my players to not use that system. So that's 1 resources load all, 2 resources load all, maybe 3. So three took like 5 seconds. And anyway, the point I want to make, I don't want to get too deep into like my implementation and what I had to do to fix it. What I do want to get into is this like API that Unity uses that is seemingly a really convenient way to access arbitrary files in a fast way without having to like set up variables and drop stuff into boxes. You can use the benefit that resources.load gives is you can use your hierarchy to enforce the structure of your game. So you can like, based on how you set up these files, and this is like not how it's set up anymore, you can tell your game like what things are available. So if I'm working on a new mode and I'm not ready for it to be in the game yet, I just don't put that folder into the resources folder, and then it won't load, into the game by default. Same with the characters, same with skins, hats, whatever, and that's useful. But it turns out that this Unity provided API is actually like super slow on some platforms, including Switch, and so it's like not great to use. What they recommend is asset bundles, and that's the Switch recommendation and all the other console recommendations, and also just like Unity in general's recommendation. I didn't switch to asset bundles. I haven't needed to do that yet. The game, I don't have enough textures and sounds and all that jazz to like feel like I really need that, because I can just reference on a game object and it's fine. But I just wanted to call out resources.log as bad and something you should avoid. The other thing I'll point out is that instead of like the alternative to using that, I just like set up in the inspector like a bunch of drop slots for all this stuff. Previously I was using the file structure to like enforce what modes are available. Now I just say here's a list of all of the scenes, and for each of the scenes there are certain payloads that can be used. If it's an arena, I've got like each of the mode payloads, which is just a prefab that has like the setup of like the soccer goals and the the paintball spawning point and the coin cloud that like flies around and drops money. And so it's a little bit more work where I have to like manually drag prefabs and stuff, but it ends up being much faster to load the game on boot, which is something that will affect every user. So it's definitely worth my effort there. What else did I have to switch? And I believe the characters are the same idea, where I just like filled out a list here instead of loading from resources. Totally fine. Nothing too crazy. And this This is literally, like, this is a very small, but also the only reason that I was using resources load is I didn't want to do this. It was faster for me to just put them in a folder, since I was going to put them in a folder anyway. Yeah. I don't want to get too much into Overdraw. Starting to run out of energy a little bit. In optimizing this map specifically, Overdraw was one of the biggest issues I had. Notably, and this is kind of a silly problem, but when the buildings, as I mentioned, the buildings regrow, when they would regrow, I set up programmatically to shake, you know, the building shakes as it's coming up. I set that up to programmatically, I shake the number of times I set, and then it would, you know, shake that number of times. But I also hooked up in that logic for each shake, spawn 3 prefabs of VFX of the building growing back, and that was when I did that the first time. I only shook, let's say, 3 times, and so it's like, okay, that's only 9 particle systems. You could obviously reduce that by making it be 1 effect instead of 3, but I didn't do that. Thought it was no big deal. Then I moved it up to 8, and so now we've got 24 particle systems spawning over the course of, like, what is it? Pre-kit cooldown, repair time, over the course of like 1.5 seconds, and each one of those particles lasts about a second. So a lot of them are overlapping. Like maybe like 18 of them are overlapping per building, and then you knock over 2 buildings that are like kind of in Z, like in a straight line of each other. Suddenly you've got like 40 particles overlapping. Let alone more than that, and so like then you've got in each particle maybe you've got like 25 sprites of like some amount of alpha overlapping. So now you're at so now you've got 40 times 25 particles. They're all overlapping some amount, so that's like 800. Now 800. Some pixels on the screen where they're overlapping are being drawn 800 times, and then suddenly your game is like chugging like crazy because some pixels are being drawn 800 times. And that's what I was running into. It's kind of funny because I didn't, when it started happening, I was like, oh no, my physics must be, my physics bar in the profiler is going to be super high. And then I kept looking and optimizing it, and it's like, no, this really is not bad. Kind of matches all the other maps, but you know, this was the problem I was having. And once I realized that Overdraw was my issue, then I just, like I said, I just changed the number of, instead of spawning 3 particles every time there's a shake, I spawned 1 particle every second shake or something like that, and I made the one, you know, I made the 1 particle bigger. So I got rid of that overdraw problem, and now the arena runs, I think it runs at 60 until you're at like 7 players, and then it runs a little bit lower than that, and then with 8 it runs at around 40, and that's still higher than my target. So that worked out well. So that's that. The other thing that, and this applies to the whole game, and this is how I got, you know, this is how I hit my target across the game, is on my players, here's Scout. I can't, let me actually like play the game, because you need to see it on the player once they've been set up. The prefab version doesn't have all the setup on it. Okay. Pump a Scout. Okay. Let's turn off Scout. Where is our niche? There we go. Okay, so you can see that he's right on top of the gizmo. Okay. So you can see that there's a bunch of it's kind of hard to tell. There's a bunch of these green circles, and they're overlapping a lot. And that's because the way that the animals' bodies work is that they're a series of joints going up the body, each connected to the previous joint, and they all kind of try to stay aligned as they were when the character spawns. So they're trying to stay straight, but you know, the player can like flop the head around, and they're all like physics enabled, and so when you run, your head kind of like lags behind, and then when you stop, it kind of like flops back until it's steady again. But in this chain, each rigid body, each one of these joints is a rigid body, and it has physics on it, and thereby is being resolved against everything in the scene, every frame. And for each character, that's, you know, that's like 11 or 12 like colliders and rigid bodies, and that's like, that's not crazy. But when there's eight players, that becomes, you know, 96, between 88 and 96 rigid body colliders, which are, you know, they're dynamic, so that's the most expensive kind. And the way a physics engine works is you have to collide every dynamic moving object. You have to test that against everything else in the scene to see if it's affected. And when you have, you know, when you have 8 players and 12, you know, physics colliders each, that adds up really fast to be kind of an exponential problem where all 12 colliders from all 8 players all have to collide with all of the other colliders on all of the other players, plus all of the other colliders in the entire scene. And so it just becomes like, it really is exponential. And so, you know, the players were obviously the biggest source of physics problems, or not physics problems, but like physics CPU time in the game, of them, like, of running through every collider in the player, and then running every collider in the player against every collider in the scene, which includes every other collider on every other player. And so I didn't realize this until recently, but an obvious way to solve that problem is just to turn off any colliders that you don't need or that aren't as important as other colliders. And so along this body, and it's super hard to tell. I think a good way to illustrate this is if I just put a mesh renderer with a sphere. Let's filter, sphere. This is too big. We're gonna scale them down. And how do I? Here's what I'll do. Fuck. Yes, okay. Create 3D game object, sphere. Oh, I didn't like that. Sphere. Yeah, I think this will illustrate the point well, if I can. It's gonna take a second to set this up. The idea is that the neck is made of these sphere colliders, and all of the sphere colliders overlap the neighboring sphere colliders to some extent, and because of that, it's okay if you turn off some of them, because they mostly overlap. Yeah, this is good. So this is about what the player's body looks like. Is that right? Yeah, okay. There we go. Okay. So this is if you were to render a sphere at each of the colliders along the body, this is what they would look like. If I go through and start disabling some of them, if I do all the evens, boom, we still have a pretty good approximation of the body. Like it's totally fine. Let me, oops. That's okay. There. So here we've got a pretty good approximation of the body. There's a couple more we can remove. 7 is like not really doing much. And then 1 is not really doing much. Because we've got the... And then there's also like... one I didn't add a sphere for is the body, and that one's kind of like there. So now, even though we've turned off a bunch of the colliders, we've got a really good approximation of the body still. And this, you know, the stuff that the body can hit, even if we like, oops, even if we like bend a bit, that still looks pretty good. Yeah, that's like a really good approximation. So and so now we like lose some of the kind of result of that exponential growth. Now instead of being 11 or 12 colliders, now we're down to like 4 or 5, and so the like 12 times 12, 144, I think. Instead of having 144 resolutions of just the player's body, and now it's more like 5 times 5, which is only 25, and you can kind of see how that results in like pretty huge savings. And that was kind of when I finally figured that out, I thought of it as like the thing that was going to save performance in the game, and it kind of has been that. And it didn't. I had a few people play the game, and they literally couldn't tell that it was different, except the frame rate being better. That's good. The only other thing, and this is kind of like a code specific thing, and also a Unity specific thing. In Unity, the operator for comparing two objects, whether that's a component or an entire game object or a rigid body or any kind of Unityism behavior, C# object, the operator for comparing those two things is overridden in the C++ side of Unity in a more complex, more expensive way than is common in C# object compares. And Unity has a blog post that talks about why they chose to do this. And they have since like reneged on wanting to have done this, but now it's like far enough in where if they were to make this change to fix this problem, which causes a performance problem in a lot of games, especially on mobile and on Switch, they would break a lot of Unity projects, so they're not sure if they want to do it. But the way to get around this, and the thing that I learned from watching a Unite talk about the game Goner, which came out on Switch in the summer, I think it was like maybe August or July. Whenever they would, instead of checking if an object was null, if a component reference was null, they would, normally you often keep references to components, and then before you use the component you want to check if it's null, otherwise you'll have an error, or maybe you'll know that you need to get a reference again, or maybe you do like a lazy kind of initialization where the first time you need something, that's when you get the component. You know, that's totally normal. But then as a result, every time you're checking, every time you're grabbing that component, you check if it's null, and that's an expensive operation now. And so that, that's happening every frame, maybe tons of times per frame. And so it's a huge problem. In Sausage, this was a huge problem for me because I do this, the way my players are structured is each one of the states they can be in, whether that's grounded or in the air or dashing or doing a stomp or being hit, like reacting to a hit. Each of those is like a discrete state of the player, and that state is a component, and that component is a component. Yeah, it's a component. Each one of those components defines its own update, fixed update, on collision enter, on collision exit, all this stuff. And as a result of that, because it's separate from the player, I have to be able to reference the player. I have to reference the physics part of the player. I have to reference the input part of the player. And to make it easy to access those components, but also to ensure that I have a reference to those, I use this thing I mentioned, the lazy initialization, where whenever I need the component, I ensure that I get it. And if I go, depending on which one I do, player maybe, yeah. So here we have, if we don't have a player, then get the component and then return the component. The way I'm doing it now, as a result of this kind of performance issue, is I use a bool, and if the bool is set to false, which it is by default, then we get the player, and then we set the bool using a null check. Like if we did get a player, then set this to be true, and then we won't have to check next time, and we also won't have to do the expensive object compare, which is also used when you check if something is null. Instead, we'll just check the bool, which is just a bit, and if it's true, then we don't go into that, and we just return the player. And I didn't count, and maybe I could, but I would guess that this null check kind of thing was happening every update and fixed update, hundreds, if not 1,000 times per frame. Probably 1,000 times per frame, especially when there's 8 players on screen, and it's an expensive operation. So maybe it takes like 1/100th of a millisecond, and then if you multiply that by 1,000, that's like 10 milliseconds or something. So, and that that adds up to be like 1/8 of the frame time I have to do the game. So it's I think it's since been fixed in every spot, and this I knew about this problem before this week, but the previous time I did it, I apparently didn't cover all cases, so I still had a handful more, and the handful I missed seemed to be used pretty often in fixed updates, so it gave me back some good gains. That's the last optimization stuff I want to talk about. I think that was pretty good. It was maybe a little technical, but it's definitely useful stuff. That said, that's all I want to talk about, so I'm going to hop off pretty soon here. If there are any questions, I can answer those. Yeah, otherwise I'm going to get off. Definitely thanks for coming by, though. I didn't. There's a thing on my list, broad phase versus narrow phase, that I didn't talk about, but I feel like I'm already past the kind of physics discussion, so maybe I'll come back to that in another week. Alright, looks like there are no questions, so I'm gonna head out. Thanks for coming. See you next week.